Good morning. Whether you're working on a basic web service or building an internal cloud for one of the world's biggest hyperscalers, Backend APIs are everywhere. Have you ever had your SLI all of a sudden tank in production, only to find that when you dig into it, it's due to a client sending a bad request? A little bit of extra thought put into your Backend API design from the start may have avoided a late night wake up and the ensuing customer confusion. Hi, my name's Sam Dunster. I was born on the South Coast in New South Wales, and I now work for Meta in California. I learned about the importance of good backend API design the hard way. APIs are everywhere. There's really two kinds that I want to touch on today. The first is public APIs. These are usually accessed over the public internet. Other organizations are usually consuming these. And there's a lot of information out there online about how you can design these well. Write good documentation and think about how your customers are going to use them. What I want to focus on today, though, is backend APIs. These are internal to your company, usually, right? They'll be derived from SLAs or agreements that are made between different teams at the company. Sometimes they're even operated just within a service or within a team. Turns out these are still critically important, though, and they're often not treated with the same kind of care. So why is it important to design your backend API well? There's a lot of good reasons to think carefully about it. The first one is operational toil. We hear about this all the time. If you design your API well, then you can expect your team will have less production incidents and different issues to deal with in production. The second one is you can supercharge your SLI. Your SLI is calculated from the different successes and fails that make up your response types, right? And you don't want the client errors that I was mentioning earlier to cause it to tank and when it's not really your fault. You might still have a lot of users, even though this is a back-end service. There could be a lot of different teams at your company or using this. And when you add up all of the time of these different teams implementing your API, you owe it to them to make it still easy to implement, intuitive, etc. Doing a good job also helps your team reputation and shows that you have service maturity. So with that, like I said at the start, we've got a lot of back-end services at Meta with varying degrees of good API design. I've got some tips I've built up as both a consumer and a creator of APIs. Let's go through them now. Number one, ensure you speak the same language. Naming is hard. We all know this. There's a lot of different things to name in all of our different systems. The first one I want to cover is what I call allocated IDs. So these are things that we usually assign to like objects or resources in a system that are created on demand, maybe through automation, right? Maybe the customer has a script that generates these things, and they want something to be able to identify this. It doesn't really matter what it is. The next type is things that are named by the customer themselves, or maybe by you if you're using your own service. Sometimes, so these ones tend to be used for things that maybe are created once or twice, like maybe when a customer first onboards to the system, they create a project or something like that, and they want to have a name that identifies that thing so that they can use it in their CLIs and all of the rest of that, but it's still meaningful, unlike an ID. Sometimes you want to allow for both as well. Sometimes you allocate a generated ID, but then allow the user to also specify a name if they think it's appropriate. So if you decide you're going to generate an ID, you can use auto increment. It's dead simple. You just specify this, your database will automatically allocate the next integer available in the system. And because there's a single thing that's allocating this, you don't have to worry about collisions or anything like that. It works pretty well, but I think sometimes it might make sense to use something a little bit more powerful from the start. It might pay off in the long run. Why not try a string? Sure, it's a little bit less efficient on the database. It's a little bit of extra work also to generate it, for sure, and you might have to deal with collisions, especially if you've got multiple different instances allocating IDs. But it could be a lot nicer for your users. You could use a UUID, but these are pretty ugly too. 36 characters, I'm not a fan of typing that. If you're using a GUI or something and you just have to click a box or select from a drop-down, something like that, it's not so bad. But you know, since we're talking about backend APIs, I expect most of the time many of us are going to be working from the CLI. Which of these would you prefer to type? Something like NanoID can really help. This is just a dead simple library. It's available in many different languages. And with just a few lines of code, you can start to generate high entropy, really short ID numbers. You can even specify an alphabet. So you can tell it to avoid characters like lookalikes, L, I, 1. This can be really neat for if you're peer programming, or maybe you're sitting next to someone in a war room dealing with a production incident, and they pull up on their screen a resource that's gone bad or needs to be looked at. And you can just punch it in quickly without getting the L's and I's mixed up. It even has a nice little web tool you can use to see just how infrequently you'll run into a collision using something like this, even with a very short number of characters. Once you have this high entropy short ID, you can even implement auto-completion really easily. With only 1, maybe 2 characters, you can really quickly jump to the object that you need to get to. 2 characters is good enough to identify thousands of objects uniquely. It can really help with your observability too, and your system tracing. If you're logging this globally unique ID from all of the different places in your system into an observability tool, it doesn't matter how many different machines it's across, you'll, with just a few short keystrokes, be able to pull up a full list of everything that's going on across your massive distributed system. All right, tip number 2, plan ahead for potentially asynchronous operations. So operations broadly can be synchronous or asynchronous. Let's talk about the differences. Synchronous operations usually involve one round trip to the server. So let's start by sending from the client to the server a request to get the information on a volume. The server receives that request, it reaches into its database, and it returns the result back to the client. There's one round trip here, client to server and back. It's all pretty straightforward. Asynchronous operations, though, are a bit more complicated. They start the same. You send a request to the server, but the server has to spin up a background thread or kick off an operation, right? Once it kicks off the operation, it needs to give the client some way to reference this operation in the future. So it returns the operation ID back to the client. The client can then later check in with the server and say, hey, is this operation done yet? The server in this case responds saying, no, it's still going, it's pending. So the client has to wait some time, and then it checks back again. This time, the operation is complete, so the server sends back done. The key point I want to make here is, well, you know, there's some changes you need to make on the server side to get this to work, right? You probably need to implement a job queue. You might have to have more complicated database. You've got to have some async tier or something to process these operations. But the thing that really matters, I think, when we're thinking about API design is the client. The client has to do a lot more work to get this flow to work correctly. They have to be able to understand what this operation ID means, and they have to build a loop to poll for changes on the server side. So if you start with a API being synchronous, and then you later want to change it to being asynchronous, your customers are going to have to go through that migration process, and it could be quite painful. So for this reason, I recommend thinking about whether something makes sense to be asynchronous from the start, even if it doesn't necessarily need it, because you think that there's going to be functionality that you're going to add in the future. Of course, you've got to be careful not to over-rotate here as well. So how do you decide? I think the first thing you should consider is time. If a synchronous operation is likely to take considerable time, it might make sense to make it asynchronous, especially if it's going to take even if it doesn't take that time at the start. My sort of feeling on this is about 30 seconds. And the reason for that is that I like my services, my backend services that actually operate these APIs, to be able to shut down in about 30 seconds. So if my longest RPC takes 30 seconds, if I tell the server it needs to shut down now, it still needs a full 30 seconds to be able to complete that last request that might have come in. So I think that's the ballpark that I like there, but you can adjust it based on how long you think your server should take to shut down. The other thing to think about is whether your operation might be interrupted and what that might mean. If there's a number of steps that make up the particular backend operation that you want to provide or you want to model, and you get partway through one of those steps or whatever, then if your service shuts down or gets interrupted, when you start back up, you might have to add a whole bunch of extra logic to be able to figure out where it was. You can also fix this with idempotency as well. But in these situations where things start to get a little bit more complicated, even if they're happening fairly quickly, it might make sense to put in that asynchronous operation from the start so that the client doesn't need to change anything later on as you change stuff on your side. Here's 4 types of APIs that I think are pretty common, right? CRUD, we've all heard about this: create, read, update, and delete. Read operations, you know, they're pretty safe to make synchronous. We want to keep these ones dead simple. There's probably a lot of clients using it. It doesn't really make sense to make them asynchronous, especially because they're usually just reaching into a database to get some information and returning it back to the client. Create, update, delete. Look, most of the time they're just a single SQL statement as well, right? You just reach into the database, you execute the change, it returns in a second. It still might make sense to make some of these asynchronous, because later on you might add functionality that makes these operations like a lot more complicated or take a lot more time. Take delete as an example. If you go to delete a row from a database, again, seems pretty trivial, but what if later on you want to also make sure that that resource that you're deleting isn't being used across any of your systems, because those systems might become inconsistent if you go and yank it out from underneath it. So make it asynchronous, and then that when you add that logic later on to go and track down that resource usage, you won't have to have your clients change anything on their side. I think this especially makes sense when you've got other things outside of this as well, right? Like mount volume, take snapshot, because some of these operations might take hours. Why not make everything asynchronous then? Good question. I mean, there is still cost with this, right? We can't go overboard here. We need to be careful. You've got to sort of evaluate the trade-offs. There is a lot of stuff you still need to do on the server side to implement all of this. And there is still some cost initially for the clients to implement that loop where they're polling for changes. All right, tip number 3, differentiate between user and infrastructure errors. If you take this as an example, there's 2 ways broadly that this particular RPC can respond to the user, right? Here we're calling get volume, and it can either return the volume struct successfully, or it would return an exception. SLI monitoring seems pretty straightforward here, right? If you get the volume back, that's a success. We don't mark down the SLI. Everything's good. If you get an exception, though, then something's not right. We should know about it, and we should account for that in our SLI. What if the user repeatedly requests a volume that just doesn't exist? That's going to return an exception as well. That's going to mark down our SLI, and we're going to look bad, even though the client's just requesting something that doesn't exist. So we should account for this. HTTP already does this. It has 400s and 500s. 400s are client errors. That usually means the client's done something wrong, and they know that they need to change something before they send that request again. That's different to 500s, though. 500s are our bad. We stuffed up. Usually the client's free to retry, refresh. Maybe it'll come good again. You should just do the same thing for your APIs. Some more examples. Client errors will be things like objects not found, invalid parameters, permission denied, that sort of stuff. Infra errors are going to be misconfigurations. Maybe the service is overloaded. These are the things that we care about including in our SLI, right? We want to know that things aren't going so well, so we can track that and improve on it over time. So what should we do? How do we actually deal with these differences? First of all, make sure it's clear to the caller. It's important for your customer to know that it's their fault versus your fault. And it's not just for the blame game. It's because then they know whether to retry or not. If it's if they've sent the wrong thing, they probably shouldn't retry. They need to change something. But if it's something to do with us, then they can throw in a few retries. That's probably fine. You could do this pretty quickly and easily with HTTP error codes. You could also do it with a Boolean flag. Next thing, you should treat them differently on your side as well. If you might want to write some middleware that processes every response you send back to your clients. That middleware could detect whether it's an infra error, client error, and then report to your SLI tracking systems as appropriate. Lastly, I would say it's best to default to things being an infra error. If you've got an error that you don't know how to categorize, default it to being infra, and then that way it'll show up, you'll get notified. Hopefully it's a quick diff for you to then recategorize that as a client error if it's appropriate. All right, tip number 4, write high-quality API documentation. Everyone's rolling their eyes. Documentation, right? This is an interface description language. I've shown a few of these so far. All of the different RPC systems, as far as I'm aware, provide this sort of stuff. It lets you describe how your API works, right? And it includes lots of information. You put RPC names in it, exceptions, all sorts of stuff. It's still rarely enough, I find. Take this example. Here we're creating a volume, and we can specify an ID or a name. Or we could specify both, or we could specify neither of them because they're optional. It's hard to know which combinations are valid. You could throw in some comments like this. I see this all the time. This isn't very useful. Don't waste your time writing documentation for this sort of stuff. What about this? So here, it's clearly saying you can pass an ID or a name. You can't pass both. That won't be valid. Or you can omit both, and we'll take care of it for you. I also threw in a megabytes here so that the units for size are clear. That sort of stuff I think is much more useful. What do you make of this one? This is a mess, right? This is trying to update a volume. Is the ID and name trying to find the volume, or is that trying to change those fields? Hard to know. What about size? If it's set, it's pretty clear we want to overwrite that. That's fine. But if you don't set it and you leave it as null, are we just supposed to leave it alone, or are we trying to zero it out or say that there's no size set for this volume? It's hard to know without docs. OK, last tip. Test your API, use it yourself. Now, we're all SREs. Integration tests are super important. Don't get me wrong, you absolutely should have these, and they give you a lot of good signal. but it can be really hard to get full coverage on integration tests. I've got a way I think you can get some additional signal nearly for free. Eat your own dog food. This is especially useful for low-level backend services. If you're providing a sort of generic thing that can be used, there's a good chance you can use it yourself within your team for something, and that gives you a lot of good signal on how your service is operating, and you get to experience it from your customer's perspective. The other thing you can do is build a CLI. CLIs are super useful for your team. You can use it to debug production issues, experiment with your own system, test it, etc. And it can also give you a way to interact with the system from languages that maybe don't have a native implementation. So you could interact with it from the shell, for example. Once you have a CLI, then you get that same sort of functionality. It's a really easy way for you to experiment with changes to your API. If you're changing something from synchronous to asynchronous, as an example, implement it first in your CLI so you can feel what your customers have to go through to migrate. Okay, let's recap. Backend API design, why is it important? It will reduce your team's operational toil. It'll power up your SLI and avoid that early morning wake up. It helps you show care for your customers' time and builds your team's reputation and service maturity. And the 5 tips: ensure you speak the same language, think carefully about your IDs, plan ahead for potentially asynchronous operations, especially if, so you can avoid that expensive migration later on. Differentiate between user and infrastructure errors. Make sure that your SLI is representing just the stuff that you care about. Write high-quality API documentation. Focus on those edge cases. And lastly, test your API. Use it yourself. Eat your own dog food and make a CLI. Thank you. My name is Sam. Thanks for coming to my talk. You can contact me here. I'll be around on Slack for a bit as well. Can I take any questions?